Large language models, they kind of feel like magic, don't they? I mean, they can whip up code, tackle super complex questions, even write a poem on the spot. But here's the thing. Behind all that magic, there's a huge challenge. How do we actually make sure these models are reliable and high quality, especially when you're trying to scale up? Well, that's exactly what we're going to dig into today. I mean, this is it, right? This is the big question that every single person building with AI has to face. If you're putting a product out there, you can't just cross your fingers and hope it's giving good answers. You've got to know. So how in the world do you get past that vague good feeling about your AI's performance and get to something real? So when it comes to testing, we've kind of been stuck between two worlds. On one hand, you've got what we'll call vibes-based testing. You know what I mean? You poke it a few times, check a couple of responses, and if it feels okay, you ship it. The problem? It's slow, it's totally subjective, and it just doesn't scale. And then on the other side, you have the dream, metric-based testing. We're talking fast, objective, and completely automated. All right, let's dive a little deeper into this whole vibes problem. Because, look, for a quick demo to show your boss, maybe it's fine. But the second you try to build a real professional product that people depend on, it becomes a massive roadblock. Yeah, there are really two huge issues here. First up is just scale. To really be confident, you need to test hundreds, maybe even thousands of different questions. And trying to do that by hand, it's just not possible. And the second thing is speed. This manual checking thing, it turns into the biggest bottleneck you can imagine in your development cycle. It just grinds everything to a halt. Okay, so if manual testing is the villain in this story, then what's the hero? Well, the hero is a smart, automated QA pipeline. It's designed to systematically test and score your AI's performance, all without a human having to lift a finger. And what's great is that this pipeline is actually really simple in its design. It all boils down to three key stages. First, we generate a whole bunch of test data. Then we evaluate the AI's answers using some objective rules. And finally, we report all the results in a nice, clean summary. So let's break each of those down one by one. All right, stage one, generation. Look, you can't test an AI without good test questions, right? But where do you get them? Well, here's the really clever part. We get the system to create its own exam. So check this out. We start by feeding the pipeline a source document. Let's say it's a technical manual or something. The system then reads that document, automatically comes up with relevant questions based on it, and then gets the AI to answer them. Just like that, we've instantly created all the raw material we need for the entire testing process. And boom, here's the output. It's just a clean, simple JSON file with a bunch of question and answer pairs. Each one of these is basically a ready-made test case, all set for the next stage. And this is the key takeaway, right? We've just automated what is usually the most boring, tedious part of building a test suite. Okay, on to stage two. Now that we have all our Q&A pairs, how do we actually grade them? Here's what we don't do. We don't ask another LLM to just get a feel for the answer. No way. Instead, we use cold, hard, deterministic logic. What we do is score each answer using really simple, objective rules. You can call them heuristics. So in this example, we've got two main things we're checking. First, a conciseness check. Super simple. Was the answer under the word limit, yes or no? That's worth 60% of the score. Second, a citation check. Did the AI actually cite its source correctly from the document? That's the other 40%. See, there's no subjectivity here. It's just a simple pass or fail. And here you can see it all in action. Every single answer gets a concrete score, from 0 to 1. A perfect answer, that gets a 1.0. An answer that, say, Mr. Citation, maybe that gets a 0.76. And all of a sudden, quality isn't just a vibe anymore. It's a real number that you can actually track and improve. All right, that brings us to the final stage, reporting. Because look, having all this data is great, but it's not much good unless it's presented in a way that's actually useful for the team. So the pipeline just spits out this clean, time-stamped report automatically. And it gives you that perfect bird's eye view at a glance. You get the average score, the median, and, this is super important, the minimum score. That immediately shows you your absolute worst performing edge cases. Okay, so we have a report. It tells us exactly how our AI is doing. That by itself is a massive step up. But this next part, this is where things go from being just smart to honestly kind of brilliant. This is the secret sauce. So you've got this report, right? It says your average score is, say, 0.74, and you're failing some of the citation checks. Now, the obvious next step would be for a developer to go in and start tweaking the system instructions by hand, right? But what if you didn't have to do that? This is the incredible part. You take that performance report and you feed it back into another AI, a coding agent. And you basically tell it, hey, here's your report card, you're failing on citations, and you're a bit too wordy sometimes. Now go rewrite your own instructions to fix these problems. The AI literally analyzes its own failures and then spits out the exact changes needed to improve itself. It's wild. What this creates is this amazing recursive improvement loop. Test, grade, fix, and then do it all over again, and it's all automated. So what does this actually look like in the real world? What kind of impact does it have? Well, the results really do speak for themselves. In one real-world test run on a set of 50 technical questions, the initial score was a pretty mediocre 0.74. But after just one cycle of letting the AI analyze the report and improve its own prompt, that score jumped to an incredible 0.98. I mean, that's the difference between a shaky prototype and a system you can actually ship to users. And the long-term benefits here are just massive. For one, you can run this entire QA suite every single time you push a change. That's called regression testing, and it means new updates won't accidentally break old features. You can also use this to easily compare different AI models, like Gemini Flash versus Pro, to see which one gives you the best bang for your buck. And finally, you get this automatically generated paper trail that actually proves how reliable your AI is. So look, trusting your gut, it's a fine place to start. But what a process like this really shows is that when you're building professional-grade AI, there is absolutely no substitute for solid automated testing. It really leaves us with a perfect mantra for this new age of AI. Trust is good, but automated QA is better.